Hello everyone, my name is Viraj, and today we'll be looking at the 19th problem from the CP-31 sheet by TLE Eliminators under the 900 rated questions. Let's go. So moved on to my sheet over here, ticked off 900, and I'll go to the 19th problem, old grasshopper. Let's read this. The grasshopper is located on a numeric axis at the point with coordinate x0, that's something like a starting coordinate. Having nothing else to do, he starts jumping between integer points on the axis, making each jump from a point with coordinate x with a distance d to the left moves the grasshopper to a point with x minus d coordinate, and if he jumps to the right, then he moves to a coordinate with x plus d as the value. Alright, now the grasshopper is fond of positive integers, so for each integer I starting with 1, the following holds. Exactly I minutes after the jump he makes with the distance exactly of I. So in the first minute, he jumps by 1, then by 2, and so on. The direction of the jump is determined as follows. If the point where the grasshopper was before the jump has an even coordinate, the grasshopper jumps to the left, otherwise he jumps to the right. Okay, for example, they've given you a neat example over here. After 18 consecutive jumps, he arrives at the point coordinate 7. He will jump by a distance of 19 to the right, since 7 is an odd number, and then he'll land at 26. And then after 26 also what happens? They've given you, we'll of course generalize the problem. So what are we trying to find? We are trying to find exactly which point the grasshopper will be after n jumps. Alright, great. So let us generalize this problem. Okay, it's a bit harsh problem since the statement is a bit long, but I'll try my best to keep it fairly simple. We first have to imagine a simple 1D axis, that is a coordinate system. Alright, I'll draw it like this. This is, let's say, the coordinate system. It extends to infinity over here, and it extends to negative infinity over here. You can understand that simply like a number line. Okay. Now, initially the grasshopper is at a coordinate that is x0. Okay, there's a grasshopper, he's at the coordinate x0. He's trying to jump. He jumps like this. So basically, he makes 1 unit of jump, 2 unit of jump, 3 unit of jump, 4 unit of jump, and so forth and so on. This extends. So first time he makes 1 unit of jump, then 2 units of jumps, then 3 units of jumps, then 4, and so forth and so on. So now the next question would be, where does he jump? If right now this is the point the grasshopper is at, is he jumping to the left? Is he jumping to the right? This is actually determined by whatever coordinate you are standing at, is it odd or even? If you think it's actually odd, then you have to jump to the right. So I'll write it over here. Odd means you have to jump to the right. And what does even mean? Even mean you have to jump to the left. So what does this mean? Right now the grasshopper will stay at x0. The whole procedure starts. Grasshopper says, okay, I want to make a unit jump of 1. Now if, assuming, let's say, just for a simple doubt, let's say x0 is even. So what will happen is, if it's even, I have to jump to the left. So from x0, I would jump 1 unit to the left. Probably this unit technically would be something like x0 minus 1. Okay, for example, let's take a very simple example. Let's say right now, x0 was 0. So if you want to make 1 jump and 0 is treated as even, you would jump 1 to the left, that is negative 1. Now the next time, when the second jump happens, you want to jump 2 units because it's the second jump. So we move on, we say, okay, I am making the second jump, that is of 2 units. Now, right now I am at the location of negative 1. Negative 1 by its virtue is odd. So I would want to jump 2 units to the right. Now negative 1, 2 units to the right makes me negative 1 to 0, 0 to 1. So you basically make the grasshopper jump to positive 1. Now you go and say, let's perform the third jump. Third jump, it dictates you're basically trying to jump 3 units as a distance. So you will say, okay, let's say if I want to jump 3 units, where should I make it now the call? Left or right? Let's see. 1 is treated as odd, so that means I want to go right. So from 1, I move 3 more to the right. That basically lands me at 4. This is simple mathematics, 1, then 2, then 3, then 4. So you basically land at the coordinate 4. And now we can, of course, presume how the simulation works. Somehow or the other, you just keep on jumping here and here and here, and you start to cover whatever number of jumps is given. Now the number of jumps over here is actually controlled by the variable n. What does that n mean? Simple, that right now when we did this simulation, we executed jump 1, then jump 2, then jump 3, then jump 4 and so forth. How many jumps would you want to execute? That is actually this variable n. Let's say n, for example, is 6. Then I would say after I have executed the 6th jump of 6 units, of course, because every jump I is of exactly I units. This is what this line technically meant. I've just generalized this quickly for your understanding. We realized that, okay, this is where I need to stop. And where do I start off with? I just took a simple example where I made starts with 0, but then it's not limited. This start can be any coordinate x0, which means in the problem, I'll be given x0 and I'll be given n. x0, again, I'll define, means the coordinate of the initial position of Grasshopper, and n means number of jumps. Great. So let's say n was given 6. There was some x0 given, for this case, let's say 0. So what is the final answer that we print? We figure out where would the Grasshopper land had x0 been 0, and were you calculating your answer after the 6th jump? Right now, I think we did simulation till totally, I think, so this was first jump, then second jump, then third jump, then you will have some 4th jump again, 5th jump again, and then 6th jump. Wherever you finally land at, this is what you print as an answer. Okay, so I'll just roughly take this. For example, let's say n was given 3. Just remove this case because I've calculated till now. But you can figure this out with a pen and paper. If let's say n was given 3, x0 was 0, then what should have been your answer? Of course, your answer should have been actually 4. You would have printed answer equals to 4. Right? Why? Simple, because this was actually the coordinate the Grasshopper landed at after the 3rd jump. This was the first one that we made, this was the second one that we made, and this was the 3rd one. Okay, so simple question. It's mostly about the simulation part that should be very, very clear in your mind. Give the problem a 2-minute thought now, and you will definitely figure out the idea of how is the Grasshopper jumping. All right, so we have discussed one test case, n equals to 3 and x0 equals to 0. Let's actually take one more. Simple enough. Let's say they have given you right now x0 is 0 and n is 1. So that's the first jump. What answer do they want to report? -1. Come back, you can see, yes, -1 is the answer. Same test case continued. Let's say 0, 2. That means x0 being 0, you want the second jump answer. That is, of course, 1. So you come back, you can see it's 1. All right, so we just talked about the simulation for x0 being 0. Then if let's say x0 is 10, then what's the value after the 10th jump, coordinate of the 10th jump, similarly, so forth. This goes on and on. Okay, so I think the problem is clear. We have discussed enough test cases. This should not be an issue now. Let's actually see what's the expected time complexity in this problem. Very important. All right, great. So now I know that 1 second typically allows me 10 raised to 8 elementary operations. Okay, this is something I know by far. Now over here, it's been given that one test runs in a time limit of 1 second, which means that one test also allows me 10 raised to 8 elementary operations. Great. Now inside a test, there is actually test cases, all right, which is given by this variable t that is in 10 power 4 order, which means if I talk about the number of operations I am allowed to perform for every test case, then basically that is 10 power 8 upon 10 power 4, which is 10 power 4 order. All right. Now this is not very large. This basically tells me you can perform 10 power 4 on an average operations for every test case. Now, every test case has this x0 value, which is very large, by the way. It's in 10 power 14 order, extends to negative 10 power 14 order. Similarly, with n is also very large. The number of jumps is in 10 power 14 order. Now, what is this indicating me? I have a very low range of operations I can do for every test case. But the n and x0, as in the variables, are given very, very large. So if roughly, let's say I'm talking about a 10 power 14 order, do you think that n being roughly, let's say in 10 power 14 order, can I create something like an O of n solution? No, of course, right? I cannot do that. I need something lower than this. Now, O of n solutions right off the bat, if is out of the mind, we know that anything above this is not going to work, n square and all that part, it's not going to work. We need to even lower our time complexity, and to be very specific, by experience, such a high constraint hints that we look for, let's say, either a log solution, all right? We create something like, let's say, log base 2 of n solution, because this definitely fits. Log base 2 of 10 power 14 would be very, very small. Or best case, we actually create something constant, something like O of 1. So this is going to work. So solutions like this are promoted. They make sense. This is something like I'm getting a hint over here, but solutions like this don't work. And this is my expected time complexity discussion. And now this is very important because What is this going to hint me in? If I'm looking for solutions that are probably in like log complexities or constant complexities, that means some mathematics is involved, right? Because if you are able to come up with some observations by looking at some good number of test cases, maybe you derive some formulas, and from those formulas, if you just plug in values, maybe you're able to get the answers pretty quickly, which will promote complexities that looks like this. And this is why expected time complexity is important, because such a high constraint has now clearly depicted that please think towards some mathematics. Don't try to actually simulate this whole idea, right? Don't try to say, let's maintain some variables, let's go for a simulation on the Grasshopper. That's not going to work. We need some acute mathematics in this. All right. So this is very, very clear. I hope this should make sense. Let's move on to the main solution. Now that we have discussed this part, as I mentioned previously also, we are looking for some mathematics, which means we are looking for some formulas, which of course means I need to analyze some cases. To be very specific, if I am a beginner, I would try to analyze a lot number of cases and try to find some patterns. Maybe there is something hidden in that, which gives me some good intuition of creating a formula. So for that, I would have a very simple technique. All right. First of all, I'll ask myself, I am looking right now at two variables. One is x0 in the problem, one is n. All right. Now, two variables, both are very large. So this is not going to be good for me, since I will not be able to create a lot of test cases and analyze something good. To analyze something good, I need that at least one of them, it goes, for example, let's say constant for some period of time. Let's say I fix x0 to some value, and let's analyze for different n. Let's make x0 specifically to be 0. Now, why does this help? x0 0 means my start position is 0. 0 means origin. Everything is very easy to analyze when we are looking for origin. This is a simple stuff in mathematics also. Mostly formulas are looked at a point of view when we start off with origins, and then is we try to move around stuff. So for this, I have drawn a quick diagram for you over here. What I have done over here is I have noted down, so this is the line that is going for number of jumps. Let's say you have 0th jump, first jump, second jump, third jump, and fourth jump. And what I've done is I've done a quick calculation in mind with the diagram piece also. What is that coordinate where you land at for that jump? So this line is coordinates. So 0th coordinate, -1 coordinate, 1 coordinate, 4 coordinate, 0 coordinate. So this is, I have done a simple mapping over here. I've done this till 12 jumps. Not after that. Maybe you can do this after that in your pen and copy. I have done till here because up till this point, it's pretty much easy to analyze some patterns. All right. So to take this help, first, let me quickly explain to you how is this coordinates coming so that there is no confusion in that part. Let's look at the diagram that I've drawn over here. I've drawn a rough diagram over here. I took the number line and I said, let's start with 0. So remaining as 0, you have basically done 0 jumps. I just noted this on. For 0th jump or 0 jumps, you are standing at the coordinate 0. Now let's say you did 1 jump. So because 0 is even, you would have gone to the left. You are at -1. For the 1 jump, I note down -1. Now for 2, I would of course next come to 1. So that means for 2, I will note down 1. Then for the third jump, I would go to 4. So for 3, I would note down 4. Then for the fourth jump, I would be going back to 0. Why 0? Because 4 is even. So I want to go to the left. So 4 units to the left brings me back to 0. So for 4, I'll note down 0. And this is the process I've continued. We go to -5, then we go to 1, then we go to 8, then we come back to 0. So I just noted these values, -5, 1, 8, 0. And then after that, I've not drawn over here, but you can draw this on your pen and paper. You will see -9, 1, 12, and 0. All right, this coming up, and after this remains same. Okay, great. So now why have I done this is because I now can look at a pattern. Can you? Right? Let's try to see. Can you see over here that a very quick pattern over here? I can see that after every 4 periods of jumps, I am coming back at 0. Yes? Basically, if you are at 0, answer is 0. If you are at 4, answer is 0. If you are at 8, answer is 0. If you are at 12, answer is 0. And I can assure you, because I'm not drawn over here because I knew the observations, I had done this for the next, let's say 10, 15 cases also. If you do this on a pen and paper, you will see for all the next 16, 20, 24, 28 jump, you will actually land back at 0. Now, this is a very important observation. What this is telling me is, can I generalize now? Like for all the n's, let's say, which are actually divisible by 4, as in which when n mod 4 gives me 0, can I say that the answer is actually 0? Can I say that the coordinate I would land at is actually 0? Assuming, again, this is a case when I have fixed x naught equals to 0. This is true. So this is some sort of an observation where I have now covered every case which is a multiple of 4. Now let's try to see. Let's see what happens when actually you look at the coordinates, next coordinate just next to this. So you have 0, 4, 8, 12. You figured out the answer for them. Let's just see the next values. If the 1 jump, 5 jump, 9 jump, and I have not written out where 13 jump would be considered, you can see that actually the answer is -1, -5, -9, and for 13, this should have been -13. I can assure you. What is this indicating? This is indicating that for all the jumps, very important, listen this to carefully, for all the n values as in jump, where you actually get a remainder 1, answer is actually turning out to be -n. Now I'm getting all these patterns because I'm analyzing this very, very importantly, that I am looking at patterns of 4. This is, initially I observed that 0 was there, and after that I tried to break it up. I said, okay, I can see that there are sort of like 4 blocks which are analyzable for me. And that's why I'm getting this intuition that n mod 4 equals to 0 gave me some different answer. It gave me for short something that's generalized at 0. Now n mod 4 if is 1, then it's giving me answer that's -n. Let's extend this. Do you think you find some pattern for n mod 4 equals to 2? Now, of course, since you analyzed the part over here, you will see this very clearly. For n mod 4 equals to 2, as in for 2 case, 6 case, and so on, 10 case, and then 14 case, and so forth. 14 case and so forth, you actually receive always a constant answer that is 1. Very easily observable, which means that n mod 4 is giving me 2, then the answer becomes 1. Now, of course, this is no-brainer. Since we have covered n mod 4 equals to 0, n mod 4 equals to 1, n mod 4 equals to 2, we would, of course, now talk about n mod 4 equals to 3. So now, if n mod 4 gives you 3, you're basically looking at the value 4, 8, 12, and then so forth. If you were talking about the 15th jump, answer would have been actually 16. Now, why is this pattern coming up? Again, very easy. This is just no-brainer, very kiddish series sort of a practice you can see over here. If this is n, then you're basically looking at n plus 1. So if you are talking about the 3rd jump, you print the answer 4. 7 jump, you print the answer 8. 11 jump, you print the answer 12. And for 15 jump, you would have print the answer 16. Which means that if n mod 4 gives you 3, basically your answer is n plus 1. And voila, we have solved most part of the problem. Why? Because now that we made one parameter constant, that is x not equal to 0, we basically generalized all the cases that were out there for n just by quick series observations, right? Now I can accumulate my conclusion like this. Now we have solved much part of the problem. Your next question, of course, would be, sir, what about not trying with x not equals to 0? What happens when x not changes? So this is where a very clever idea will come into picture. I'll try to relate this in this diagram over here. Now, you must know or you must have heard of problems where there is a change of origin, right? We can imagine that right now x naught being 0 was an origin. And now that we are pitching that x naught changes, it basically means we are changing origin. As in we are trying to replace 0 with some other value. Now I'll try to reason a very important thing. What was 0 by nature? To start this off, 0 was even. Now because 0 was even, you went to the left. Now you found, of course, a odd natured element, so you went to the right. Then again an odd natured element, you went to the right. And then you came back to the left because this was even. To code this back, go over here. You have this 0. This is of course going to be an even one. So you did a left over here. Then this is where you did a right because negative n means mod 4 equal to 1. So negative n as in this, whatever is this value should have been odd. So you took a right. Then of course 1 has to be a right. So from 1 you would have taken a right again. And then if n mod 4 give you 3, then n plus 1 would be again even. So this would have forced you to do a left. So you can write it over here that you did a left, right, right, and left in a very general case. Now this is when 0 was even and you started off and this went left, right, right, left. Now imagine this. Let's say this x naught would have been some other number which was still even. Let's say I replace it. Now x naught has become, let's say, 2. Can you imagine what will happen? Try to imagine this. I'm trying to draw this with a pen. Imagine that this number line is controllable. Okay, keep your fingers like this and see that if you can move this number line a bit. So just keeping all my rest of the diagram constant, imagine that I move the number line like this. 1, 2. Shift it like this. Now, if you shift this origin, if you shift or replace 0 by 2, what happens is all these values become something like this. This becomes, so whatever are these right now values, let's say this is 0. So this becomes 0 plus 2. Yes, this coordinate becomes 2. What does this become? This becomes negative 1 plus 2. This becomes 1. What does this become? This becomes negative 5 plus 2. This becomes 4 plus 2. This becomes 1 plus 2. This becomes 8 plus 2. You can imagine that you've basically transformed all the current answers to places by in the plus direction, or basically in more towards their right direction, right? This should make sense. So assuming x is still even, okay, let's say this, I'll not now take, let's say 2. Let's say this is some z where z is even. My answer can simply be said as something like this. Let's say after everything, you have something like a final pause position, something like a final position. You can just change this final position to be x naught plus final position. Okay, this is a very important idea. X naught is even. This is the whole clever part in the problem. I'll repeat this again. We have first understood what happens when x naught is 0. We figured out that we have very general answers and quick methods to get the correct value of the coordinate. We have 0, negative n, 1, n plus 1. This is sort of the pattern that follows. So as soon as we plug n, we get the final position. But that final position is only limited when x naught was 0. When x naught is not 0, it's a different number. It's of course some number that has this x naught value. I say if x naught is even, since the geometry of going left, then right, right, left remains same, you can imagine that all answers have been shifted by those x naught value. Or you can say now your origin is x naught. So x naught plus is what you get the final position. This is very, very, very important. All right. And now, of course, the next part of the question would be, sir, we have covered if x naught is even. What happens when x naught is odd? Right. That's the only other case that's left. All cases covered when x naught is even. So if x naught is odd, this is again going to be a very important part. You calculate the final position, assuming x naught was 0. But then you don't print the answer as final position. What do you print the answer? You print the answer as x naught minus final position. Okay. Now, why is this going to happen? I'll give you a simple idea on this. Let's come back. When we calculated these answers, our idea started from left, right, right, left. Now imagine, right now, you started with this number being even. That's why you went to left. Then you went to right, then you went to right, then you went to left. Do you think by the symmetry or mirror symmetry, to be very specific, if this is not 0, this starting point is actually 1. Now 1 is actually odd in nature. What would have happened is, now your initial move would not have been in the left direction. Because it's odd, it would force you to move in the right direction. Okay, great. Let's move in the right direction. From 1, if I would have jumped 1, then you would have gone to 2. Now 2 is basically an even part. Now this is an even number. You would have forced, so right now, I'll note this down. You went right. Then you would have gone left. So you would have went to 0. So this is left. Now 0 is again even. So you would have went to left and you would have, I think, landed at, you can imagine, -2, and then this is -3. So you would have went to -3, and then -3 by virtue would have been odd, so you would have gone to right. But if you just draw this sort of a test case, what is the difference that is happening over here? Can you see all the lefts that we did now became right? We initially were left, right, right, left. Now we are right, left, left, right. So this change that happened, can we imagine that there was a mirror of symmetry? Because you started with odds now, basically all this simulation, all these arrows that I drew like this, then this, and this, basically will look like this. This, back, and like this. Just the mirror symmetry. And because of this, we can imagine that our answer or the final position that we calculate with respect to the origin has been shifted in the different mirror direction. That means if for even it remained plus, then for odd it will become minus. So origin, that's the correct origin, whatever you can call that, correct starting coordinate to be specific x0 from x0 minus final position. This is actually the right answer. All right, I hope this is as clear as day. This is very important. There is definitely a requirement for you to sit down with pen and paper and draw some cases to get this mirror idea that we are talking about. I'll do a quick run on the test cases so that we cross verify that our answer is right. Some big case, let's say something like this. All right, so this is 10 and 99. So you have over here x0 equals to 10, and then you have n equals to 99. Now over here, assuming that x0 was 0, let's get the final answer. So if x0 is 0, I know for n, 99, I have to take which value? 99 mod 4 technically would have given you, I think, 3. Yes, 3. So we would want to print the answer as 100. So right now our answer is 100. Now let's go to x0. Actual x0 is actually 10, which is actually even. So for even, I would want that in this 10 value, I add 100, which means I get 10 plus 100 as an answer, which is 110. Let's go back, see, yes, 110 is our answer. All right, and if you run this idea on all these bigger cases also, it's going to work as expected. Great. So a good problem. Let us actually look at the code part now to understand this whole idea. As I dictated the whole intuitions over here, same is going to be the code. You have this start and the jumps that are basically there. That's n and x0 basically, right? So I have a final pause variable. Now if jumps, which is n basically, is mod 4 giving me 1, then final pause is negative of n, so negative jumps. If it's giving me mod 2, then it's 1. If it's mod 4 basically gives me 3, so sorry, right? Mod 4 gives me 2, then it's 1. Mod 4 gives me 3, then it's jumps plus 1, or basically n plus 1. And if mod 4 gives me 0, it's basically 0. So now after this simple if checks, I have final position calculated. To that final position, either I will start at the start value, or from that start value subtract that, dependent on what is the nature of start, or basically x0, starting coordinate. If x0 is even, then start plus final position gets stored back in the final position only. I don't want it an extra variable. Else from start minus final position, you subtract that and you store it back. Then you print final position. If you can see very easily, if I run this, my idea follows, everything passes. It's going to get you accepted on the platform also. All right, and what about the time and space now? Everything is constant because we don't have any extra space that we can count from only variables, and then we are not working with any simulation because we have neatly figured out a quick formula for our whole simulation process. So we have pretty much if and else checks only, that's constant. So I can report time to be O of 1, space to be of 1, and this actually relates with the whole expected time complexity idea that we knew beforehand we are looking for something that's constant, or in log parts to be specific, but then we figured out something constant. That's great. We knew that we were looking in that direction only, and that was only helpful or only possible with mathematics, which is clearly over here. I have used that. Okay, great. So that is all that is there in the problem. I hope you like the video. Thank you for watching.